Sector the Chem channel will be always helping you on chemistry difficulties.
This lesson is for WAEC Chemistry titration question. I don't have time to waste. If you are ready for this lesson, then look for writing materials and then you copy this question. This is about 99% question you'll be expecting to write on Wednesday. Let's see how I predicted my question. Now, we all know that our solution, which is A, is what? Sulphuric acid, which contain 5.6 cm³ of concentrated sulphuric acid per dm³ of solution. The concentrated acid has density of 1.84 gram cm³, and then percentage purity is equal to 98%. Then B is the solution of sodium containing 4.0 gram per dm³. Now this is your base. Now 25 cm³ of B was pipetted into conical flask and titrate against a using methyl orange indicator. So titration table, this is my own titration value, the practical value. I don't know how your own will be based on your initial and then your final, but what you need to know is at the end you have the average value of 12.13 cm³. So now these are the questions that you need to put your attention on. Now you must be asked to calculate the average titre value, and then secondly you must be asked to calculate the concentration of sodium in gram per dm³, which already we have in our question. That one, there is no need for you to calculate it since we already have it in our question. So you must be asked to calculate the concentration of sodium hydroxide in a mole per dm³. And then 3, you must use this formula CAVA all over CB VB equal to NA all over NB to calculate the what? Concentration of sulphuric acid, that's CA. And then you must calculate the number of mole of sodium hydroxide, and that one you may calculate it. So now 5, now you may be asked to calculate the number of mole of sulphuric acid reacted, and then 6, you must calculate the mass concentration of sulphuric acid in gram per dm³. Then 7, you must calculate, or you may calculate the percentage purity of sulphuric acid. Now solutions, let's see how we calculate everything. Now this is solution to our question. 1, your average titre value, and this is the average titre value that I got from my titration, where I add the 3 titre values and then divide by 3. Then it gives me my average volume of acid used, which is 12.13 cm³. Then the next question is for you to calculate the concentration of sodium hydroxide in gram per dm³. Although I told you before that from the question already we have concentration of sodium hydroxide, which is 4.0 gram per dm³. So what we have to calculate now is 2 now in mole per dm³. So a mass of sodium is 23 plus mass of oxygen is 16 plus mass of hydrogen, which is 1. When you add everything, you are going to get 40 gram per mole. So the formula you have to use in calculating concentration of sodium hydroxide in mole per dm³ is concentration is equal to mass concentration over molar mass. So when you substitute, you now have 4.0 divided by 40. What you have as your answer of concentration of sodium hydroxide in mole per dm³ is 0.10 mole per dm³. Then the next question, which is question 3, you have to calculate the concentration of sulphuric acid using CAVA CBVB equal to NA divided by NB. Now from our balancing chemical equation, we have sulphuric acid plus sodium hydroxide giving us sodium sulfide plus water. Therefore the mole ratio of Na to Nb, that's acid to base, is equal to 1:2, because our sodium contains 2 mole while our sulphuric acid contains only 1 mole. So the formula you are using is CAVA all over CBVB equal to Na all over NB. So once if you substitute, this is what you have. You now first solve the denominator. After when you solve everything, you can follow this how they solve it, and then you cross multiply. So your final answer here, your final answer for CA is equal to 0.103 mole per dm³. Question 4, you have to calculate the number of moles of sodium hydroxide used. So we have formula here, and our formula here is equal to N is equal to CV, and our plus C is the concentration of sodium hydroxide, which already we have calculated, and then V is the volume. So now you first of all you have to convert the volume of sodium hydroxide, and we all know that we prepare 25 cm³ of sodium hydroxide. So when you divide 25.0 divided by 1000, you will get 0.025 dm³. When you substitute that, N is equal to 0.10 times 0.025, you will get 0.0025 mole. This is our number of mole of sodium hydroxide, and then the feed is for you to calculate the number of moles of sulfuric acid reacted. So from the equation of the reaction, we all know that acid is to ratio base is equal to 1:2. So therefore moles of sulfuric acid is equal to, now since acid is equal to base, sulfuric acid is equal to sodium hydroxide, so we are dividing the number of mole of sodium hydroxide by 2. So once if we do that, we will now have 0.00125 mole of sulfuric acid, and then 6, we are to calculate the mass concentration of sulfuric acid. A molar mass of sulfuric acid, which we have 2 times 1, and then 2 times 1 is coming from 2 of hydrogen, and then the mass of hydrogen is 1 plus 32. 32 is coming from sulfur, then plus 4 times 16. 4 is 4 of oxygen, and then 16 is the mass of oxygen. So when we multiply and add everything, what we will get as the molar mass is 98 gram per mole. The formula we use here is mass concentration is equal to molar concentration times molar mass. We already have the molar concentration of acid, which is 0.103 times molar mass, and our molar mass is equal to 98. So once if we do that, we now have 10.094 gram per dm³. So now the next question, which is question 7, is calculate the percentage purity of sulfuric acid, and then step 1 for calculating the mass of impure concentrated acid formula. Now mass is equal to volume times density. We have already calculated the pure concentration of sulfuric acid. Now this is impure. Now mass is equal to volume times density, and the volume we are using is the volume that is given in our question. If you remember, 5.60 times 1.84, which is the value of density. Once if we multiply that, we will get 10.304 gram. So step 2, in step 2, mass of pure sulfuric acid from titration already calculated in equation 6, which is in equation 6. This is what we calculated. So now when we come down, we now have step 3, percentage purity. So the formula of percentage purity is equal to mass of pure substance all over mass of impure substance times 100. Once we will substitute and then we divide and multiply, what we will get is 97.96%, and when we approximate, we have 98%. So this is our final answer for the suspected question that WAEC may ask on Wednesday.
Thank you for watching this lesson. If you found this lesson useful to you, don't forget to like, share, and subscribe to this channel if you have not subscribed to this channel, and also hit the notification bell for more chemistry lessons.